So we're going to be talking about polynomials today, and we're going to start by specifically naming the different kinds of polynomials or types of polynomials. And the best way to identify these types of polynomials is by looking at the prefix of the word. So for instance, let's look at monomial. So mono means one, and so this means one term. So the actual definition, if you want to think about what is an actual monomial, is that it can be a number, or it can be a variable, or it can be the product of these two things. So an example of a monomial could be 5, just the number 5, or it could be like x, or it could be a product of numbers like and variables like 12xy squared. Okay, something like that. So for binomial, we'll start by looking at the prefix bi, and of course this means two. So binomials are two terms. So two terms, we're going to say that the definition is that we're looking at the sum or the difference of two terms. So why would we have the sum or difference of two terms? Well, the reason why you end up with that is because the terms you have are not like terms, so you can't add them together. So an example of a binomial might be something like x plus 3. Or another example could be like 2w minus 5. So in both of those cases, those are binomials because I have two terms and they're added, addition or subtraction, and I can't combine them because they're not like terms. So now let's look at trinomials, and of course tri means 3. So we've got 3 terms, and of course this is the sum or difference of 3 terms. So an example of a trinomial could be this guy. Right? We've seen these guys before. These are quadratics. Now the word polynomial is reserved for when you have more than 3 terms, or it's sort of a generic way to talk about a monomial, binomial, or trinomial. The word poly, or the prefix poly, just means many. Okay? So this is the sum or difference of many terms, and the many is kind of generic here. So this is like the generic name. So an example of a polynomial might be any of the above listed examples, or something that looks like this. So this guy has 4 terms. When we look at polynomials, it's really important that we all have a common vocabulary for talking about the parts of the polynomial, especially later when we start solving problems like these and we want to talk about the different parts, like this part does this and this part does that. So one of the most important things in a polynomial is this guy right here. Okay, he's the number that's attached to the term that has the highest exponent, and he is called the leading coefficient. So why are we looking at the 12 and not the 9 and not the 2 and not the 1? It isn't because the 12 is in front. It's because the 12 is attached to this guy. Okay? He's the highest exponent in the entire polynomial. This guy is going to tell us the degree of the polynomial. So that's the highest exponent. Okay? One last little part of this polynomial that's really important, and this is going to come up later, is this guy over here. You might know notice that of all the things in the polynomial, this guy is kind of on the outs. He's the only guy that doesn't have a variable attached to him. He's called the constant. And the constant is always just a regular number or a real number. So let's talk about the degree of a polynomial, because the degree of a polynomial is a really important part that tells us about the way the graph is going to look, and it tells us about how many solutions we're going to be able to find if we try to solve these polynomials. So we want to look at the degree. Now there's two different ways to talk about the degree of a polynomial, okay? So first we're going to talk about the degree of a monomial. In other words, how do you find the degree of like just a term, like one term, okay? That's going to be the sum of its exponents. Okay. If you want to find the degree of the entire polynomial, right, that has lots of different terms, okay, that's going to be the highest degree of all the terms in the polynomial. So these can be confusing because if you just say find the degree and you don't specify which kind you want, the degree of the monomial or the degree of the polynomial, it's hard for people to be able to tell you the right answer. So let's look at some examples. State the degree of each one. So you see this guy's just a monomial right here, right? He's just a monomial. So all I have to do is look for the sum of the exponents, right, of his exponents. And you can see that the degree here is just 5. All he has is a 5. So the degree here is 5. Here's another monomial, right? So if we're going to find the degree of this guy, we're going to have to add or take the sum of all the exponents. So remember that this z actually has a 1 for his exponent. So that's going to be 3 for the y, 5 for the w, and 1 for the z. So the degree here is going to be 9. Now the last one is a polynomial. So I'm going to look at the degree of each one of these guys separately, and then whoever has the highest degree gets to be the degree for the entire polynomial. So this guy has degree 2, this guy has degree 4, and this guy has degree 0 because he doesn't have any variables. Oh, actually, I think that's supposed to be a z. Let's go back. So this guy actually has degree 1. That's supposed to be a z right there. I don't know why it's not showing up. Okay, so of all these numbers, 2, 4, or 1, which number is the highest? Well, the highest degree here is degree 4, and so this polynomial would be degree 4. All right, let's talk a little bit about operations on polynomials. Operations is just a fancy way of saying addition, subtraction, division, multiplication, exponents, all those good things. So when combining polynomials through addition, subtraction, or multiplication, we often need to use the distributive property. Right? Remember, we use the distributive property because we want to drop the parentheses. So for this problem, I'm going to end up distributing here, and then rewriting this, and then combining like terms. So this would be 3x squared minus 12x plus 7. Over here, when I distribute, I'm going to get plus 12x squared. Be careful because you'll notice that I did a minus times a minus, right? And that's going to change the sign. That's how I ended up with positive 12x squared. Then I'm going to end up with minus 6x, and then again I'm going to end up with a positive 2. So because I was distributing a negative 2, it ended up changing all the signs. So now we can collect like terms. So this guy is going to get added to this guy, and this guy is going to get added to this guy, and this guy is going to get added to this guy. So I'm going to end up with 15x squared minus 18x plus 9 is my final answer. Same thing on problem number 3. We're going to distribute, right? So this guy's going to multiply here, and here, and here, and we're going to come up with 6x to the, remember we're going to add the exponents when we multiply, so this is x to the 5th, minus 21x to the 4th, minus 12x cubed. And since none of these are like terms, that's as simple as that one can get, and I have to leave it just like that. All right, let's take a look at the back side of the notes. We're going to be multiplying two binomials together, and we're going to use FOIL. Remember what FOIL stands for. Firsts, outsides, insides, lasts. It's just a way of remembering to distribute everything. So for instance, firsts, outsides, insides, lasts. So this problem becomes 2x squared plus x minus 8x minus 4. And again, I have to make sure I work to combine like terms before I give my final answer. It would be 2x squared minus 7x minus 4. Okay. How about x minus 3 squared? Some of us might be tempted to just square the x and square the 3. But remember, exponents mean multiply by itself 2 times. So this is x minus 3 times x minus 3. Now we can FOIL this guy out. I'm going to get x squared minus 3x minus 3x plus 9. When I combine like terms, I get x squared minus 6x plus 9. Sometimes I have a binomial multiplied by a trinomial, and I have to distribute not 4 times, but 6 times. So 3 times with the x, and then 3 more times with the 2. This is going to become x cubed minus 2x squared minus 15x when I multiply everything by x. When I multiply everything by 2, I get 2x squared minus 4x minus 30. If I combine like terms, right, these guys were like terms and these guys were like terms, I end up with x cubed minus 19x minus 30. When you have x minus 4 or a binomial raised to the third power, sometimes the easiest thing to do is just to write it out. This is x plus 4 times x plus 4 squared. So this is x plus 4 times x squared plus 8x plus 16. Let's try that again. Plus 16. So I'm going to be distributing this guy. I'm going to first multiply everything by x, then everything by the 4. And when I multiply this whole thing out, I end up with x cubed plus 12x plus, x squared plus 48x plus 64. So there's a couple special products which can save us a lot of time, effort, and energy. So like for instance, number 7, we just did this the hard way. There are actually easier ways to do things. Like this one, we also did this one the hard way. There are easier ways to multiply a binomial by itself. So let's take a look at these special products. First special product we have is the difference of squares. The difference of squares is like saying that you have a squared minus b squared. A squared minus b squared is always equal to the product of their sum and their difference. I'm sure you remember doing this when you learned how to factor in Algebra 1. For squaring binomials, remember to square a binomial is just to multiply it by itself. So a plus b times a plus b. We can go the long way and we can FOIL, or we can learn that when you do this process, the first number gets squared, right? A times a. The last number gets squared, b times b, and the middle number is the product of these, right? AB and AB. So you get 2AB. Same thing happens when you have a negative. All you have to do is change the middle sign. So you'll have a squared and b squared, but this time because you have a negative here, this will be minus 2ab. Lastly, for cubing binomials, the easiest way to cube a binomial is to use Pascal's triangle, which we'll talk more about later this year. If you aren't sure what to do, start by writing a plus b times a plus b squared. Then you can always FOIL this out. But a shortcut way of looking at it is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, how did I know that this number was going to be a 1, this number was going to be a 3, this number was going to be a 3, and this number was going to be a 1? I used the third row of Pascal's triangle. Remember what Pascal's triangle is? You start with a 1, you write 2 1s underneath it. These 2 1s add up to 2. These two numbers add up to 3. These two numbers add up to 3. And this is a 1 again. So I'm really just using these numbers, right, to find out what would happen if you took two values and you cubed it. These would be the coefficients if you took two values and squared them, and these would be the coefficients if you took two values and raised it to the first power. So using the same strategy for a minus b quantity cubed, I would get 1 a cubed, but then because the b is negative, this would be minus 3 a squared b. Then this is plus, because we're squaring b. And then the last term again is going to be negative. So the negatives are alternating. So that's what it looks like to have a shortcut for cubing binomials.